Hello again, pre-calculus people. So today we're going to be talking about piecewise functions, which you've seen them in the past. You've seen them a little tiny bit in Algebra 2, and you've certainly seen graphs that are piecewise functions. They just may not have been called that. And the goal today is to be able to do two things. One, just evaluate a piecewise function at a given x value, and also to be able to graph a piecewise function appropriately by hand. So what is a piecewise function? Well, just like the name implies, it's a function that might be defined by two or more things. In other words, it's a function that's kind of in pieces, right? But the one thing about piecewise function, remember, is those pieces are not going to overlap, okay? It's just never going to happen. Well, I mean, if it does overlap, it's not a function, but they are not going to overlap. Okay, and I'll kind of revisit that when we get into the graphic part of this. So this is what a function would look like, right? This has two pieces. We'll see one down below here that has three. But basically what you want to do is look at the kind of second part of each line. This part right here is what we call the domain restriction. And this tells you what x values it is that each line is valid for. Okay, so if you look at like the top one, x squared minus 4, that's saying that that function is only defined for values less than or equal to -1, or you could write that from negative infinity to -1, including -1, so we'd use a bracket. So any x value you see that's less than or equal to -1, we're going to just plug into that top function and get that answer. Similar thing on the bottom, right? So 2x plus 3, that function is only defined for x values greater than -1. So from -1 all the way to infinity, then we're going to use the bottom function. So when we're evaluating, depending on what x value we're given, the first question we say is, okay, are we going to use the top or the bottom function? Then once we do, we just plug it in there, get the answer, and you're done. They're only going to have one answer for each x value. It's still just going to be a function, okay? So we look at this. So my first one is f at -3. So you say to yourself, okay, where does -3 fall? Is it less than or equal to -1, or is it greater than -1? Well, -3 is obviously less than, so we're going to use the top equation and then just plug it in. So it would be -3 squared minus 4, which would be 9 minus 4, which is 5, and that is your answer. You move on to the next question. Okay, x value, which one does it go into? Plug it in, done. Next one, if x is equal to 4, again, where does it fall into? 4 is greater than -1, so you plug it in here. So that's going to be the bottom equation. So you plug it into here. So 2 times 4 plus 3, 8 plus 3, 11. Next question. Okay. The only ones you got to be a little bit careful about sometimes is the numbers on what I call the boundary. So like if x is -1, again, you're only going to plug it into one place. But look where it can be equal to -1. And in this case, it'll be that top equation again. Okay, because it can be equal to -1 on that. On the bottom one, it's got to be greater than, so -1 does not fall into that one. So again, plug it into that top one. -1 squared minus 4 would be -3. Remember, anything negative squared is a positive. If you want to pause the video real quick, and evaluate these three, then we can do that. And then I'll go through the answers here in just 1 second. So again, if x is 2, which one does it fall into? That's going to fall into the bottom equation. So I'll plug that in. So 2 times 2 plus 3 would be equal to 7. F at 0 falls into also the top equation. Again, 0 is greater than -1. Or sorry, the bottom equation, sorry. I said bottom, I wrote top. So 0 times 2 plus 3 would be equal to 3. And then the last one, negative 5. Negative 5 is less than negative 1, so it'd be the top. And you plug that in, negative 5 squared minus 4. Again, that's 25 minus 4, so that's going to be 21. Okay? So again, figure out what your domain is for each one, and then whatever x value, wherever your given x value falls into, plug it into that one. These are all only going to have one answer. Okay? Works the exact same way for three piecewise functions. So you got 3 pieces here. So again, my top function only defined less than or equal to positive 1. So I'll go from negative infinity to positive 1 for the bracket, including 1. The middle function, notice the middle function is just constant. It's just that horizontal line at 3. But that's only going to be from 1, and again, not including 1, until 4 with a bracket, including 4. And the bottom one from 4, just past 4, all the way to infinity. So again, take these guys, plug them in, and we'll kind of go from there. Okay? So x equals 1. Again, be careful on the boundaries, which one equals 1. That'd be that top one. So you plug that in. And don't forget what absolute value does. Absolute value turns everything positive if it isn't already. So that's going to be negative 4. So because that's 2, negative 2 times 2 is negative 4. And the absolute value is only on the inside, right? It's still being multiplied by negatives. That's why the answer is still going to be a negative. If x equals 7, we look at this. So 7 is greater than 4. So that's going to be the bottom equation. You plug that into the bottom. So 6 minus 2 times 7. 6 minus 14 would be negative 8. And then this one, I think that's just a typo. I kind of read G at 1, so we'll just skip that one. Come down here to 2.5. Again, where does 2.5 fall? Well, it's not less than 1, but it is between 1 and 4. So we're going to use that middle equation. And this one's super easy because, again, there is no x to plug into. So that constant, it's whatever x is in between 1 and 4, y is always going to be 3. So it's just going to be 3, and you're done. Don't overthink that. Everywhere in that interval, it's just this. So if you were to kind of graph that piece of it, it's just going to be that little horizontal line right there. Negative 3, what does that fall into? Top equation. And again, plug it in, negative 2, absolute value, negative 3 plus 1. Again, this becomes a positive 2. Negative 3 plus 1, the absolute value of negative 2 is positive. So that becomes negative 4 again. It's actually the same answer as the previous one. And then for 10, that's obviously going to be in the bottom equation because it's greater than 4. So 6 minus 2 times 10, 6 minus 20 would be negative 14. Okay, so that's evaluating. Again, know your domain restrictions, figure out what x value, where it falls into your different domains, plug it in, get the single one answer for each one, and you move on. Let's go to graphing. And for this one, I'm actually going to use a pencil, even though I hate using pencils, because I think the easiest way to graph these things, and I've done this a few different ways, is look at the function, graph the whole thing, just like you would in previous math classes. But then look at your domain restriction and just erase what you don't want. Okay? So like on this first one here, we see our top equation. This is y equals 2x minus 1. Okay, so I know from my Algebra 1 days, I know my slope is 2 over 1. and my y-intercept is -1. So I'm going to come down here and just graph that line. So there's -1, slope of 2, do a few points, and go backwards. And then I'm just going to kind of sketch that line in kind of lightly. I don't want to go too dark because I am going to erase a part of it. Okay, so that would be the whole line. If you were in Algebra 1, your teacher would say, oh, that's awesome, and just kind of move on about it. But now we got to go back. Notice my domain on this is only from x is less than or equal to 0. So that means x has to be to the left of 0, right? So from here all the way down, I'm just going to make that darker. That's what I want. I don't want anything beyond 0. So I'm just going to erase everything, every part of that graph that I don't want. Okay, so that's going to be that first piece of that piecewise function. And then for the second one, again, it's just a little linear equation, 1/2 x plus 3. Slope of 1/2, y-intercept of 3. So again, graph it the same way. 1, 2, 3, put a point here. Up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. We can go backwards. And again, kind of put that in there lightly. And you're like, okay, well, what part of that do I need on that one? Well, on this one, I want only one x is greater than 0. So I'm going to make two notes here. So first of all, so I want it from here definitely greater than 0. So I'm going to make that darker so it kind of shows up a little better. I'm going to erase everything to the left of it. So remember at the beginning of the video, I said these things are not going to overlap. And you see my functions aren't overlapping. Okay. Now, the other thing, some of you might be saying, well, wait a minute, they overlap right here at 0. Well, really they don't, because if you remember, we use a closed circle on this one because that was equal to 0, so it gets a filled-in circle. But really on this one, it's going to be an open circle. So I'm going to make that into an open circle and just kind of highlight that and be able to go from there, okay? And I'm going to put a note over here. Anytime you see a greater than or equal to or less than or equal to, you're going to do a filled-in circle. If you see just a plain less than or a plain greater than, you're going to use an open circle on that x value. Okay, so don't forget that. So that's your piecewise function. Okay, again, easiest thing, graph the whole thing, and then just erase what you don't want. Okay, last one. So again, we have 3 of them here. First one is just a linear equation. So I'm going to do y equals negative x minus 3. Slope is -1. Y-intercept -3. 1, 2, 3. And again, -1, so up 1, left, up 1, do a few points here. We'll go backwards a little bit. And again, I'm just going to put that in kind of lightly, to see which points we need. Notice, I really don't even care about the domain until I get the line in there. Okay, and now I can look back and say, okay, what is my domain on that top equation? It's only for x is less than or equal to -5. Remember, x value. So you go to your x value, 1, 2, 3, 4, 5. You go up to where that line is, but it's right here. I'm going to put a filled-in circle because it's less than or equal to. And if it's less than, that means I'm going to the left. So that is going to be my top equation. Okay. For the middle one, we just have y equals 4. And remember, that is just a horizontal line. There's nothing crazy about that. A horizontal line. at y equals 4. Okay, so 1, 2, 3, 4. Again, just kind of sketch that whole line in there. Kind of hard to see because it's already on the line. But again, where do I want that? That's just from -5 to 0. And remember, both of those just have less than, so they're both going to be an open circle. So -5 is right here. So I'm going to go to -5, put an open circle. Go to 0 and put an open circle. And then I'm going to just erase everything else. So I'm going to make that a little darker because that's the section that I want. And then I'm going to erase everything else. And that's your middle equation. And then for the bottom, do the exact same thing. So y equals x squared. Remember, that's our old friend, the parabola from your algebra days. So we know the parabola starts at 0. And I forgot to erase the rest of my line back here. Sorry about that. So for the parabola, it starts at 0. And of course, if you plug in 1, 1 squared is 1, 2 squared is 4, 3 squared is 9. And we could go backwards, even though I know already that I don't have to. But that would be what the whole parabola looks like. But again, if you look at your domain, it's only for greater than or equal to 0. So I'm going to put that closed-in circle there and fill that parabola in nice and dark. And I don't need anything else down there. Okay. So again, when you're graphing these things, graph the whole graph. If it makes it a little easier for you, erase whatever it is you don't want based on your domain values. And then make sure you're using the open circles, closed circles. Okay. So that is evaluating and graphing piecewise functions. If you have questions, as always, let me know. Come to tutoring, ask some questions during class. Until next time, stay safe.